Okay, so let's actually now take what we've just learned and actually figure out the measurement in a triangle. So what I know is that this is the angle now I want to solve for. So again, I'm not solving for a side today, I'm solving for an angle. So based on this angle, this is the hypotenuse, this is the opposite, and this is the adjacent. So the ones that I have are the opposite and the hypotenuse. And I'm going to write SOHCAHTOA up here on top, just so I can use that to refer to figure out which ratio goes with which triangle. So on this triangle here, I have opposite and hypotenuse. If I look at SOHCAHTOA, I have opposite and hypotenuse, so I want my sine ratio. So I'm going to say that sine theta is opposite over hypotenuse. So in this case, I'm looking for theta, so I don't replace that. I have the opposite is 6 and the hypotenuse is 11. I just want to leave it as 6 over 11. I don't need to do some weird decimal that's really long on my calculator. I'm just going to leave it as 6 divided by 11. I'm looking for this angle, so I'm going to do what I need to do to solve for an angle now. So that means I'm going to do sine inverse. And we only use this if we're solving for an angle, not for a side. So the last 2 days we solved for sides. Today we're just solving for an angle. So now I'm going to do 6 over 11 because that's what was left on this side. And then again, that's what I get to put into my calculator. I get to do sine inverse of the relationship between the sides. So if I grab my calculator, I'm going to find sine inverse. I'm going to do bracket, and it says I want to do 6 divided by 11. So I can put 6 divided by 11 right into my calculator as is, and then I close the bracket. And then I hit equal. And it gives me the angle that relates those two side lengths. So I have 33.06 degrees. Again, if your calculator works backwards, you're going to do 6 divided by 11. And you may have to hit equals, and then you're going to do sine inverse equals again. You'll have to kind of play around and see how your calculator works. Okay, let's try this one. So again, I have this angle. This is the hypotenuse. This is the opposite, and this is the adjacent. So let's look at what side lengths we have or need. Well, we have this one, and we have this one. So it means I'm looking for an angle in this case. So opposite and hypotenuse, which means I want the sine ratio again. Opposite and hypotenuse. So I'm going to say that I have sine theta is equal to opposite over hypotenuse. So I have sine theta, opposite is 25, hypotenuse is 32. So I'm looking for an angle. So I'm going to say theta is equal to sine inverse, and then I'm going to do 25 divided by 32. I don't change that. I don't need to do anything. I can just put it in my calculator like that. So then theta equals, so I'm going to grab my calculator. I'm going to do sine inverse, bracket, and then I want to do 25 divided by 32 and close those brackets. Then I want to hit equal. And so that's the angle that goes right here that relates those two side lengths. So I got 51.375, so really 51.38. So I'm going to write 51.38 degrees. Okay, let's try a few more. So if I look at this one here, there's my angle. This is the hypotenuse. This is the opposite. This is the adjacent. So I have the adjacent and the hypotenuse. So I'm looking for which ratio would I use the adjacent and the hypotenuse in so that I can find this angle. So that would be my cosine ratio. So I'm going to say that I have cos theta is equal to adjacent over hypotenuse. So I have cos theta, adjacent would be 14, hypotenuse would be 19. So I don't cross multiply again. That would be for a side length that I would do that. I'm looking for an angle. So we do a little bit differently. Again, we're going to do cos inverse 14 over 19. So I can put this right into my calculator. So I can do cos inverse bracket 14 divided by 19, close bracket. And then I'm going to hit equals. And I get 42.536, so really I get 42.54. So I'm going to say 42.54 degrees. Okay, let's try the one next to it. So there's the angle. There's the hypotenuse, longest side. This is opposite it. This is adjacent. So there's my hypotenuse. There's my adjacent. So I'm looking for something that has hypotenuse and adjacent. So again, that would be my cosine ratio. So I'm going to say, well, this is cos theta is equal to adjacent over hypotenuse. So cos theta, my adjacent was 0.7, my hypotenuse was 1.8. So I can say that theta is equal to cos inverse of 0.7 over 1.8. I'm going to put that in my calculator. Again, if your calculator works backwards, you're going to do this divided by this, and then do cos inverse of that answer. So I'm going to go right my normal way. And I have 0.7, and I'm going to divide that by 1.8, and I'm going to close bracket. And so the angle in that triangle would be 67.11. Okay, two more. So if I look at this one, there's my angle. Longest side is the hypotenuse. This is opposite. This is adjacent. So I have the opposite and the adjacent. So I want something that has opposite and adjacent, so I would probably pick the tan ratio. So tan theta is opposite over adjacent. So tan theta, the opposite is 127, the adjacent is 113, 113. I want to do tan inverse of 127 over 113. So I'm going to put that into my calculator. So I want to do tan inverse of bracket 127 divided by 113. That's not what went in, so I'm going to delete that. So again, I want 127 divided by, oh, and I forgot my brackets now. Bracket 120. Let's start that again. So I want to do tan inverse bracket of 127 divided by 113, close bracket, equals. And I get 44.34 if I'm rounding. So 48.34 if I'm rounding. Sorry, 48.34, perfect. Okay, last one. There's my angle. Hypotenuse is the longest side. There's opposite, there's adjacent. So there's my opposite, there's my adjacent. So again, I want the tan ratio. The one that uses opposite and adjacent. So we're looking for an angle. The opposite is 6.8, the adjacent is 1.3. So I can do tan inverse of 6.8 over 1.3. So I'm going to do tan inverse bracket of 6.8 divided by 1.3, close bracket. I'm going to hit equals and I get 79.18. So 79.18 degrees, and I'm done.